Hello world! In this video I'd like to show you the tool called Rigpp. Some time ago I already presented it. It has been much improved. The general approach of making rigs in Maya is to write Python scripts, then generate them, and here the final rig is got. I have the tool for this called Rig Builder. You can find it on GitHub. So the general approach is like this. You create modules here, like this is limp. You add parameters here, like maybe name, some joints. This is name, and this is joints, and press OK. You create nodes in Maya, and select those nodes, and here you set up parameters, set up names, and then here you write Python script that use those variables like alarm or joins, and this way the common rigs are generated. This is a very popular, and due to it it's convenient because everybody knows how to work with it. If you see on more complex modules like Biped, you see a lot of modules here like shoulders, a lot of parameters, and here is the code that is used to generate the rig. So after the rig is generated, this code is not necessary at all because you have built and everything works with Maya nodes. So this is just creation of Maya nodes and the connection of those nodes, and a lot of modules here. I always had an idea of what if not to generate rig by these modules, but to evaluate it with these modules as well. Now it's Python script that generate Maya nodes, but what if these modules will be written in maybe in Lua or in other language and be evaluated in runtime? So this is where Rigpp comes from. This is a Maya node that runs C++ in real time using LLVM and Clang. Yeah, it's nice, convenient, and even easy to use. Yeah. Let me compare it with Rig Builder. I've written the similar interface for it. It's called Rigpp Builder. This is the similar interface, so you can add modules here like this. Add module. Module is a part of rig. The approach is that you get some data from Maya, pass all this data from modules, and finally you get the final hierarchy, changed hierarchy, and the rig. So you connect the final node with the nodes in Maya, and your rig is working this way. Here you create a module, here you add attributes, and this is where you write code. This is plain C++ with math based on iMath and other additional things. Yeah, let me show you some simple example. Create simple skeleton like this. Create locator, place it here. This is aim constraint, or yeah, aim constraint, I think. Name it as test joint. This is locator. So at first, in order to work with the rigging system, you need to convert all you have into internal representation to work with it in the nodes. So you select all this, and here initial hierarchy, append. You append this hierarchy with parents, names, and matrices to attribute this node. Rename it as maybe init initial node or aim. Usually the first node is the initial node. Here you see the skeleton, skull. This means that this node contains initial hierarchy. So you can add additional nodes like this, and this node can work with the hierarchy here. This is the chain of transformers. You can understand this is a hierarchy transformer. You get hierarchy here, transform with this node, and finally you can output result somewhere. Remove this. In order to see what's happening, you need to add some output to the node to allow Maya to compute the node. Let's add some transform. I'll discuss it a bit later. So you see here that our node is a locator actually, and you can change some parameters like color, or show names, or filter by name to see joins, transforms, and etc. You can change opacity. Yeah, it's easy to visualize the results and to see what's happening, what's going on. Then we need to write some code. So all this hierarchy is available in a variable called root. And this is the hierarchy. And to get some children, you need to use macro code use transform. And this is here you write name like test1 joined, and attach this, bind this to variable like j, and another binding to log. This is just a finding in hierarchy, and if nothing was found, we informs user with an error. Then we can use some functions. I already wrote the API. It's almost done on 90%. Yeah. And I have some functions like parent or aim constraint. And here I want to aim this, and then aim vector. Aim vector is locator 1. Let's write it aim, and up by default is y-axis. Let it free. Aim is vector aim, like log translation minus j translation. All these handles are really pointers, shared pointers. And that's done. Press save code, and you see that the code compiles well. And if you write something wrong, you see errors. You change this, press save, and you can select node and see that here is source, and this code saves here. And try to move locator. Nothing is going on. That's because locator now is passive. It's not active. It's saved, and no more nodes connected to the node. We need to get locator's matrix each time, so we connect it not initial but here in matrices as well. And you see that aim constraint is working. This is simple. And return to the transform here created. This is the special kind of transform. It's custom transform that can retrieve hierarchy matrix from this virtual hierarchy. So I use some math to transform initial hierarchy, and I get joint 1, transform it, and I want to retrieve it from the system. Here, this is a parameter called parent, and I can write here the node or even to the joint. So I can move, and let me parent it here, rest, and you see that this transform has the position of the join 2 in hierarchy. So I can use this transform to retrieve some positions, some transforms. I can even, in this node, create some transforms and parent it to some other transforms, and even I can remove transforms from a skeleton. And this is I called hierarchy transformation. The next interesting thing about all this, that you can save this code to file like amcpp and use this file as input. Save, copy path, and insert it here. Press save code. Everything works as expected. Yeah, and here bytecode was created, and this is a file without any dependencies, as CPP requires runtime environment with standard CPP headers, and this is the final file, the bitcode that doesn't require any dependencies, and it's cool, and you cannot see the source if you want to hide the source. Yeah, it's nice, and actually when you load the scene with Rigpp, nodes compile the source code to the module, to the LLVM module. And if you have a bitcode, you don't need to compile, so it's the loading is much faster. Another interesting rig here is a full-featured ARM rig. Yeah, it's limp rig. It works like this. You have IK like this. You can even stretch here IK, some parameters like IK stretch. You can even snap, and you can use polyvector stretch, IK stretch. Yeah, and you can use scale factors for each part, and then go to FK. Using transforms, it's quite easy to write seamless switching. Yeah, it's nice. And CEDA code, it's very nice. I like the code because it's very simple to, it's very similar to what we have in Rigpp Builder when we build modules in. And here I have some parameters on this node like IK, snap, IK, and etc. There's a possibility to add different types of parameters like node obscures, metric strings, enums, and etc. And all these parameters immediately available here. I wrote a module. This is a CPP class called limp. It's located here in Rigpp modules. And this is a class that evaluates limp. A lot of math here, but it's all very fast and simple. And this is the setup. So if you want to evaluate single arm, you set up parameters here. If you want to create another arm, you can copy this without the definition of loop. Change parameters like left or right arm in all these places. Set up different IK parameters, create here, or maybe another way you get IK, and press save code, and you see, and you get the node that works with 2 arms. Yeah, and you can create here another module, and you can create a limb for maybe a left arm here, copy all this, paste, and set up here different parameters, and you have this. I need to press save code. Snap, I don't have these parameters here. Actually, I need to duplicate this node. It duplicates, compiles, and here it's okay. This I need to remove. Limb 1, and maybe this is right arm. You set here different parameters. Yeah, press save code. It's okay. And this is how chaining works. Actually, the root for all this is the same. Here is here I need to remove clear initial hierarchy here because I already have it here in the first node. If you select the node, open hypergraph, you see that the evaluation is like this. Limb first node, then right arm. And you can add more chain here. And this is the initial node, transforms initial hierarchy, and transfer it here. It transforms another part of Rigpp, left arm, right arm, left leg, right leg, and etc. And I think the main goal to create the easy-to-use system is to create modules like this with some parameters, and you just set up parameters here. You can even omit FK or create some simple, more simple systems, and save these modules in different files. And you can just you can create Rigpp by importing modules, ordering them, and that's all. If you want to change something, you just need to change these parameters here. Yeah, it's nice. And moreover, can I show you another example? The great thing of RiggPP is that you can cancel, or not cancel, you can bypass this evaluation. So if you have IK, remove this IK, and where is my K? I have K. IK. Actually, I can turn off the evaluation. Yeah, this is turned off, and I can copy this, create a new module here. Maybe remove this, duplicate, limb 1. That's all, and I remove from this, remove this. I can format code using Clang format, save. Yeah, that's done, and now it's working. And I forget to say that this editor supports completion, control space, and you see the completion, different parameters, blending, etc. I want to write documentation for the code for API, and by pressing help you get nice and easy to understand help here. So if you have this as initial node, here I need to clear hierarchy, and this is work as expected, and you can turn the evaluation off. Yeah, now it doesn't evaluate the code. So you can create different the stack of nodes, left arm, right arm, spine, head, and even more complex things, and you can easily turn them off or on. It's just not state. I think it's cool. You can create a lot of modules and even stretch maybe other things and just turn them off. Yeah, I think it's cool. And this is the example of using different modules. This is IK evaluation, like this. left arm, right arm. And of course this is locators, it's drawing, and I can move the drawing, I can hide, and etc. And you can turn different parts of, yeah, it's great. And I forget to told you about the drawing system, debugging system. I think it's cool. At any time of evaluation, you can draw line, draw point, or draw text to display things like numbers, weights, matrix position, to visualize what's going on, like this. Draw text. Here is position. You can use already calculated position like join 2. This is position plus maybe some vector to move it a bit upper, and the text like each class, vector, quaternion, matrix, and even hierarchy can be converted to string. And I want to convert join 2 matrix to string. And you see the change in matrix. And I think it's cool to visualize what's going on. So I almost done with the system. I'd like to write documentation, document the API, to write some examples there, and to make this tool easy to use, and to make it even public. I don't know currently. I think the idea very nice, and it's nice to create rigs using the system, and actually having a nice looking C++ code, it's not hard to implement complex things. I forget to tell you about another way to connect outputs from the internal representation to bones. It's maybe more easy and faster. It's just another node with attributes like names, and output translates and rotates. This is the math, it's easy. If you have joins already connected, already set up here as initial, and names is okay, you select this here and set up here tools, output, connect, selected. Yeah, and that's done. And the rig works for transforms. Yeah, and you see the output is just a simple node that takes hierarchy, in exec, out exec, this connection between Rigpp nodes, and outputs translates and rotates. This way is very fast. It's at least twice faster than my standard nodes, rigging my standard nodes. And actually, when the hierarchy passes through nodes, the hierarchy doesn't being copied itself. It's just a link. So you can create a lot of modules, and overhead is really, really small, like getting own attributes. It's like this. So you see performance, like getting outputs this time, and this is just the evaluation itself of this code, and overall is this time. Yeah, it's very fast. I tried to implement thousands of IK, and it's fast too. I hope you enjoy it, you like it, and maybe this tool will be published, and I hope you will join the project to help me to get this tool for making interesting rigs.